So, hey everyone, I'm Paul, and I spent the past couple months working at a company called Binary Thumb that makes a mobile app called Grid. And I'm going to talk today about how a team of 5 people who really don't think that much about databases managed to learn about DynamoDB and move onto it. So we're all pretty much front-end developers, mostly iOS developers. I come from a front-end web background. And I kind of had like, you know, in the land of the blind, the one-eyed man gets to do the back-end work kind of situation at Grid. So I talk a little bit about what our existing stack was and what you kind of need to know to use DynamoDB. This is like the stuff that isn't really that well documented. Stuff that I had to find out by going through Amazon support, and stuff I found out by like using my library card and like getting an actual book. So hopefully this presentation will save you from having to like spend a few hours Googling before you figure out if Dynamo even solves the problems that you want to use it to solve. That works too. Cool. Yes, this is here to save you some time. All right. So I'm a front-end web developer, and I'm sure there's some real database experts here, and this won't come as a surprise. This is what front-end developers kind of think of when it comes to databases, right? Like, I started out building web apps on like MySQL. It's kind of inflexible. You know, I really hate having to do migration just to add a new column to my table. Mongo, I set up with a single like apt-get install. That's awesome, right? But wait, everyone says like if you try to build something big and heavy in Mongo, that's a bad idea. So how can I get the flexibility of MongoDB with like the reliability and like really hardcore tested performance of a SQL database, right? Like people like Morton are using MySQL. The biggest user I know of MongoDB is I think Foursquare, right? Like it's just, they're not really in the same league. And when we started kind of looking in the space of things that could really scale up arbitrarily and have the flexibility of a NoSQL store, which as the past 2 presentations mentioned, that's just like a straight, usually key value store that doesn't really think too much about joins or foreign keys. We really had 2 options. And one option was Postgres with the HStore feature, which is really basically like the best of both worlds. And then there was DynamoDB. So when I investigated DynamoDB, I kind of hoped that I would get all the features of Mongo, but without having to think about the level of like setting up individual database instances. I just thought, hey, I just provision a few tables and boom, it's done. Dynamo is not that. What Dynamo is something that basically trades from you having to think about sharding on a per server basis to sharding on like a hash key basis. So you don't have to think about, oh, I need like 3 database instances and I need this much storage. Instead, you need to think about in terms of throughput, number of keys, and number of indices. Dynamo doesn't support a lot of the really nice programmer-friendly features of MongoDB. One thing I really liked about Mongo was the ability to query within objects. So I could have like one user state in a database, just like it's one huge object, one like huge tree representing the whole user state. And if I wanted like to query for the existence of something 3 levels down, even like 3 levels down, if it exists in the list, I could do that with a single query. DynamoDB doesn't let you do that because, of course, at scale, you have to think more hard about how you're going to do that. The other real bummer with DynamoDB is that you can't add indices to a table after you create it. Again, something you really can't do when you're at a massive scale, and DynamoDB is meant to work arbitrarily at any scale, so you lose that ability to do that. So DynamoDB is not like the magic hosted Mongo that I think I was hoping for. Amazon SimpleDB, on the other hand, might be what you're looking for. Every field you put in a database is indexed automatically. You can query multiple indices, go nuts, right? But you can put a maximum of 10 gigabytes in a single domain, which is, you know, essentially like a table, although more limited because I believe you cannot query across domains. And after that, you're done. You need to move on to something bigger. So it turns out Amazon SimpleDB really isn't useful for much more than like logging or for like really small pet projects. At Grid's case, we're kind of at the point where we just broke that 10 gigabyte limit for one of our tables. So it wasn't really an option for us. But I think a lot of people who are kind of interested in DynamoDB for side projects, basically SimpleDB is what you want. So it's good to look into that. What DynamoDB does do is it makes you think about your relationships in your schema. And once you do that, it's kind of set in stone. So you can kind of teach DynamoDB the relationships in your tables when you make it, and then Making a migration is kind of like you recreate your tables, you recreate your database from scratch. The anatomy of a DynamoDB table is you have to have a hash key, and that's just what Dynamo uses to shard its data across different instances. So you want to make it something evenly distributed. So a bad shard would be like the date a bad hash key would be like the date a user was created, because you get a lot of hits one day, and then suddenly all of user signups for that day are on one node. That's silly. Make it something random. And then the range key lets you do range queries. So something greater than, less than, or in between two values, you can do on a range key. You can't do a range query on a hash key, and that's that's like the first of many gotchas with DynamoDB. If you want to do something like that, you can add a local secondary index. You only get 5 per table, but it's sort of like adding a second range key to your table. So we could talk a little bit about how we're using local secondary indices with hash keys at grid, but I think like a good example is maybe using it as a date field, right? Like maybe you have a message board and you have a table for users, and then you have another table called posts, right? And your post table, you want it to be sharded on the number on which user made a post. So your hash key is the user ID, and the post ID is the range key. But you also want to sort posts by more recent. So then you add a local secondary index for when posted. And then you can do queries like, get me all the posts or before or after this date. But you have a 10 gigabyte limit for all the data that's created within one local secondary index. So if you find yourself that with a user that has more than 10 gigabytes of posts, you need to move on to a global secondary index. There's no limit on data size, but there's another limit of 5 per table, and they cost you like in money, in dollars with Amazon. You have to be very careful with how you use these things, and they actually slow down writes a lot. So when you read your database, you can choose. Amazon gives you the choice of them being strongly consistent or eventually consistent. And like for those of you, and up until me recently, haven't studied like the CAP theorem and the way database consistency works, is you can basically choose when you read to get the latest information before you read, but it costs more time, and it also costs more money. It costs more throughput. So as a UI developer, I was kind of surprised to be given that choice by my database. That's kind of an example of how DynamoDB is a very heavy-duty tool to expose a choice like that to you. It's something you probably don't want to think too much about if you're us. We're kind of just always going with strongly consistent for now. OK, so what's this throughput thing? It's basically how to measure how much Dynamo juice you're using on all of your queries and all of your tables. This is the formula it's used to calculate it. It was explained to me by Amazon support. The table is 4 secondary indices and a write throughput of 8. Then you can read 2 write units per second. So that's a 4 kilobyte unit. So that's 1 8 kilobyte row or 2 4 kilobyte rows. If you really want to see if it's cost effective, there's a nice calculator you can play with online. It's fun to try to compare this with the pricing for Amazon RDS. But really, when you're trying to calculate the price for Amazon RDS, you have to think in terms of IOPS and memory. And it's really an apples and oranges comparison. So you probably want to think more about, are my tables more read heavy or more write heavy? How big is each row in the table? And that's where you can really get a feel for whether or not Amazon DynamoDB is going to be a big win for you. This is something that actually isn't in the official Dynamo docs, but I found this in a book, an O'Reilly book. It linked to a random support thread, and it said, oh, hey, when you distribute your throughput capacity across your global secondary indices, you might find that you go over the write capacity for that index, and then it just locks the entire table. So you can't write to the table anymore until it's done writing that one index. And you can kind of get this traffic jam where it's like, oh, your table isn't processing writes for 15 minutes because you had this one secondary index you forgot about, and the table's host. And at that point, you can call support and be like, sorry, you should have paid us more money for the table because you're paying for throughput in advance. Also, secondary indices are read-only. That's another funny catch. So what I think a lot of people end up doing is these secondary indices are projected, where they'll only project the range key and the hash key on the index. So if you want to do a write or a delete on that index, you'll do a read first, and then you'll just grab the attributes you want, and then you'll do the write or the delete you want to use, because you can't actually delete or update based on those secondary indices. Another odd thing about DynamoDB that no one really seems to know about is the import-export format. I actually asked an engineer if they could explain it to me, and they said, just like fill the table with garbage data, do an export, and like look at it in a text editor, and like make your data look like that and import it. Like, are you kidding me? There actually is an obscure page in the developer's guide that does like dedicate 2 paragraphs to the format. It isn't JSON, it isn't anything, it's Amazon's random thing. And also on the phone, the engineer told me that the data imports go a lot faster, and this makes sense if you shuffle the lines in the file. So you don't want to have a bunch of inserts for the same hash key all in a row, because Amazon's trying to figure out how many instances to provision as you do your inserts. Okay. So what did we like about DynamoDB? It runs on SSD, and it's pretty fast. You can back up to S3 with a single click. And the idea is that it can kind of take you from any scale to any scale. It probably doesn't make sense for a startup that's just starting out. I think Mortem is right, where you would really want to start on like a single relational database node. But because of our kind of weird situation, we're actually starting on Redis. And we were kind of too big for the intermediate things. Like we didn't want to build on a single Mongo instance and have to scale to multiple Mongo instances. We definitely didn't want to stay on Redis. It kind of made sense for us. So it's a good like intermediate scale to huge scale database. What kind of stinks about DynamoDB? We have this weird arbitrary row size limit. It was 64 kilobytes when I started using it. They just increased it to 400 kilobytes. I don't think that's going to change anyone's use case. I think basically, if you're worried about a 64 kilobyte limit, like upping it to 400 isn't going to change your decision. But okay, you basically have to spread some of your long data between multiple rows. Really, if your data is that long, if you're storing books in Dynamo, you might want to think about using Amazon S3 instead. The web interface is horrible. Like you refresh the page and it takes you back to the home page where you list your tables. It's like there's no excuse for that. It's poorly documented, as I explained. Really, you have to use Amazon support or get an O'Reilly book to understand it. Also, the local client is really bad. It's this random Java jar that you run, and they don't really explain how it works. Some really interesting hackers built one for Ruby that mimics the protocol perfectly, and everyone really just uses that. And there's no RMs. Although I'd really like to write one. So if anyone's interested in taking that on as a project, that might be a fun open source project to work on. And there's like silly things like you can't insert or an empty string as an attribute of an object. Again, I'm not a database expert, but like these things, like they're not necessary to get the scale of DynamoDB. They're just kind of caused by laziness on the part of Amazon, I think. So I'm going to talk a little bit about Grid, the application we work on. It's like a visual spreadsheet meets something like HyperCard for the Macintosh. It's very whimsical and graphical and pretty. And we really just want to think about UI and HCI, not think about scaling. All right, so this is what our data model looks like. It's pretty simple. You have a user who has many grids, and each of the grids has many tiles. You can think of this as like maybe an accountant has a folder full of Excel files, and each Excel file contains many little tiles. But we want this to support arbitrarily many tiles for arbitrarily many grids. And you can imagine someone having 100 grids, each having 1,000 tiles. So it really just makes sense for us to focus on getting all the data for one user in one place. It seems pretty trivial. Most of the time, we'll be fine just starting by user. How are we doing this right now? Well, we're persisting all of our data in Redis. Redis isn't really for that. Most people use it for caching. It's fully in memory. The persistence across a single device is kind of broken in that it does periodic writes, but it doesn't really keep the disk in consistency with a database. And replicating across nodes, I hear, is a complete disaster, and it's really experimental. So it really became obvious that we had to move off Redis instead of just moving on to EC2 instances with bigger and bigger amounts of RAM. So I inherited this project. It was an ORM built on Redis. I actually think it would be a fun thing to write in school because it really teaches you about how indices on a database really work and how you might want to do deep reads. But it's a pretty bad thing to build a startup on. You can see what it looks like. If I want to read a user in Grid right now, I'm going to fetch a JSON blob for the user, and that just gives me like the stuff you would see in a column or in a row in a user's table. If I want to get all the grids for that user, I have to query a Redis index. And if I want to get all the grids, all the per grid data for each of those grids, I have to do a Redis get for each of those. So it's funny when you actually do grab a grid, in addition to it being present in the index, the foreign key is already duplicated in the model. This made porting to DynamoDB pretty easy, but it is also kind of silly. it kind of goes to show you that we already went out and built the foreign keys in it already. So it was almost like, why use Redis at all? At any rate, if I want to fetch all the grids for user, I have to do order n Redis fetches for order n grids. It's an in-memory lookup, but still it adds up, especially if you have 100 grids, each with 10,000 tiles. So moving into Dynamo was pretty easy. Moving the user model was actually really easy. You just set up one, you just use the primary index, the hash key is ID, boom, there you go. You fetch the user by ID. That's really all we need to do. Fetching a grid is a little bit trickier. We want to be able to pull a grid item by user ID in addition to the ID. So we had it set up with a hash key of user ID, which shards it by the user ID, and then the ID of the grid itself. But we also want to be able to read the grid just by the ID. So that requires a global secondary index, and we want to be able to read the grids in order of their updates. That requires a local secondary index. So boom, right there, that increases our throughput requirements by 3 times on that one table. Another odd bummer is that Dynamo defines a unique row as a unique combination of a hash and range key pair. So you can't really make the row's range key the updated at the time. That's kind of like what Morten was talking about, having the last few bits of the timestamp being in the key. It would be kind of cool if maybe we could, I don't know, maybe we could just like have them sequential. So like if there's already one for this timestamp, and you just add it right after that. It would make sorting by time pretty easy. It would get rid of the need for the local secondary index, but oh well. Moving the tile to Dynamo was a little bit trickier because we really wanted to be able to query within the spreadsheet itself. Like we want to be able to get everything to the right of a column or below or above a row. And we were able to do that, but we weren't able to do both at the same time because Dynamo really only lets you query by a single index at a time. So that kind of sucks, but there's really nothing that can be done about that. And geohashing really doesn't work either because, of course, geohashing requires you to know the size of your globe or the size of your space before you start geohashing, and a spreadsheet is infinitely scrollable. So if it really becomes a problem where we can't query within a viewport for grid, we'll have to move the tiles to a different database altogether. And these are our final thoughts. Starting with Redis made the transition to DynamoDB a lot easier. If we started with a SQL database, it might have pushed us over to using Postgres instead of something else. DynamoDB feels like it does everything we want it to do. We like having to think about sharding on a per user basis rather than thinking about provisioning machines and distributing users among machines. So Grid is hiring, mostly iOS people, although we also do some backend work with Node and of course Dynamo. So you should totally talk to Josh, who is in the back, if that interests you.
That's me.
And thank you.